Hi everyone. I'm trying to give you a quick overview of some of the review topics that we are covering in Pre Calc and giving you a chance to listen to this and then hopefully work in class on the assignments. So section 1.3 is looking at graphing linear equations. You can see the objectives. We're going to graph some lines. We're going to find some x and y intercepts for a line. We'll actually find the slope of a line when we're given 2 points, and we'll be able to calculate zeros of linear functions. Let's look at some terminology to begin with. First term is what a linear equation is, and it's any equation of the form ax plus by equals c. A and b both can't be 0 at the same time, otherwise that takes away all your variables. Solutions to linear equations are any ordered pairs that represent points on the graph. If you're looking at an x-intercept, that is the x value of an ordered pair where the line crosses the x-axis. The y-intercept is the y value of an ordered pair where the line crosses the y-axis. Hopefully these seem like familiar terms. The slope of a non-vertical line is the ratio of the change in the y values to the corresponding change in x values. You can also think about it as a rise over run. For a line, the slope will always remain constant. And this should seem like a very familiar formula to you. Change in y is usually described as y sub 2 minus y sub 1, and divide that by the change in x, which is usually labeled as x sub 2 minus x sub 1. Remember, x sub 1, y sub 1 is one ordered pair on the line, and x sub 2, y sub 2 is another ordered pair on the line. Just make sure when you're subtracting your y values and x values that you subtract in the same direction. Continue with some other terminology. Let's actually look at some forms for linear equations. The first form is standard form, and that looks similar to what we just were introduced to on the last slide. It is ax plus by equals c. You just have to make sure in standard form that a is non-negative and that a, b, and c are not fractions or decimals. So keep a positive, or if the x term doesn't exist, then I guess it's 0, that's fine, but no fractions or decimals. Slope-intercept form is another common popular form to use for linear equations. That is your form y equals mx plus b. M is the slope and b is the y-intercept of that line. Makes it easy to graph the line when it's in that form. There are 4 common types of slopes out there that we should be familiar with and be able to decipher. The first one is a positive slope, which would be any line that is going upward from left to right. A negative slope would be a line that travels downward from left to right. Zero slope would be the slope of every horizontal line, and every vertical line has an undefined or no slope. And the last slide of information, a linear function, let's get rid of the y and replace it with f of x, give it some function notation. So f of x is equal to mx plus b. M and b are real numbers, and we're actually used to m and b being the slope and the y-intercept. Equations for vertical lines are the only types of linear equations that cannot be representing functions because a vertical line will not pass the vertical line test. And just keep in mind, if you are writing an equation for a vertical line, it will take on the form x equals c, where c is any real number, so x is the only variable within the equation. Zeros of a function. Zeros of a function are the same as a function's x-intercepts. They are the places where the graph crosses the x-axis, and in order to find them, you replace f of x or y with 0 and go through the process of solving for x. When m actually equals 0, you end up canceling out the x term a part of the linear function. And what you are left with is what is called a constant function. It actually represents a horizontal line. And there are no zeros to that horizontal line unless the horizontal line is actually your x-axis. Moving on to examples, we're asked to start by graphing x plus 4y plus 5 equals 0. And we're going to find x and y intercepts in order to graph. In order to find x and y intercepts, I am going to do just one quick switch to the equation. I'm going to move the 5 over to the other side and put it in basically standard form. To find the x-intercept, I'm really just going to cover up the y variable. And when I cover up the y variable and solve for x, it pretty quickly solves for x being equal to -5. So that's your x-intercept. Do a similar process to find the y-intercept. Cover up the x variable and solve for y in the equation 4y equals -5. And all I have to do is divide both sides by 4. So I get y to equal -5/4. If I plot the x-intercept on the x-axis and the y-intercept on the y-axis, so -5 got plotted on the x-axis, -5/4 got plotted on the y-axis, and I connect those points. Not a great job of drawing my line, but pretty close. I think you get the idea. Example number 2, graph 2y minus 3x equals 9 using the y-intercept and the slope. In order to do that, I need to get it in the slope-intercept form. So I'm going to get the y variable or y term by itself. I'm moving the -3x over to the right-hand side to make it positive. The plus 9 stays on the right-hand side. I'm going to divide every term by 2. And if I use my slope and my y-intercept to graph, I start with the y-intercept, and that would be 9/2 or 4.5. And once I plot 4.5 on the y-axis, I will use the slope of 3/2 to get another point. So I can go up 3 and over 2, both of them positive, or I can move down 3 and 2 to the left, 2 movements that are negative, connecting those points. A little better there than the last problem. That should give me the nice graph of that linear equation. Our last example, looking for zeros of functions and then graphing the function. Remember to find zeros, you replace f of x or y with a 0 and you solve for x. So if I bring the -x over to the left-hand side, I get x equals -3, and that would be our 0. Remember that also represents the x-intercept, so I could plot that point on the x-axis. I know that the graph has to go through that point. But I also know that the original function is really in slope-intercept form, and I can use that to plot points as well. That would tell me that the y-intercept, that -3 on the end, tells me the y-intercept is -3. The slope is -1, so I could go up 1 and 1 to the left, or I could go down 1 and 1 to the right. All of those points, all 4 of those points lie on the same line, and that's the line that I'm graphing to represent that problem. Last example, f of x equals 3. If I replace f of x with 0 in that problem, there is no x variable, so I cannot solve for x. This doesn't have any zeros, so I'm going to write none down for zeros. But take a look at what that equation represents. If I get it into the form of y equals instead of f of x, y equals 3 is a nice equation for a horizontal line. Every point on that line has a y value of 3. So all I'm going to do, I can plot 3 on the y-axis and draw a horizontal line to the right and to the left using that. And that completes the idea of the material coming from section 1.3. We'll get you the assignment soon. Thanks for listening. Bye.